Thank you and welcome, ladies and gentlemen. I have the honor today to travel with you into a fascinating world, the world of smart grids. And the journey will actually have 3 destinations. And the first destination will be dawn of the urban millennium. And I think that is important as an introduction to understand why do we need smart grids. Then, as a second destination, we will look a little bit into what does it make to pioneer the smart grid. And then we will directly from there deep dive into one topic around smart metering, which is of particular interest because it certainly also affects a lot of, or all of us at the end, because we are all consumers of energy. And this is then very close to the point of consumption. Here are a few figures, and I mean, probably you are all aware that the world is not only growing, it's also much faster growing in the cities than on the countryside. And here are only a few numbers. In 2007, 50% of the world's population was living in cities, and that was an increase from 3.5 billion to 4.7 billion, as we expect until 2030. Furthermore, 50% of the world's GDP is produced in cities with a population over 750K. And last but not least, 75% of energy is consumed in cities, but 80% of the CO2 emissions of the greenhouse gases are produced in these cities. So this is pretty impressive, and it's even stronger than if you reduce the number of cities to the real megacities, which according to common definition are cities with more than 15 million inhabitants. And I mean, probably most of you are aware where these megacities are located. If you take the 10 biggest ones, only 2 are in traditional economies like Japan and the United States, namely Tokyo and New York. All of the other ones are really in emerging markets and emerging countries. And that the ratio will be even stronger in that direction if we look ahead in 10 or 15 years. There are already around 200 million the cities of 1 million inhabitants in China. So if we talk about these topics, we have to have a perspective very much also on the fast developing economies like the BRIC countries, Brazil, Russia, India, China. So from there, what are the drivers, or what are the basic needs? And actually these basic needs listed here are not only common sense, they are the feedback of a survey that has been done. And for most of the people asked in this survey, efficient transportation of people, goods and energy was the most important need for future cities. I mean, most of you know it, especially if you're living in a big city like London or even a mega city like Mexico City or like Sao Paulo. You know, if you go from your home to work, it takes you hours, even for little distances. And that is also certainly true for goods and energy. For example, also energy supply. If you have a small brownout in an area in Sao Paulo, just because the distribution lines are hit by trees. It takes hours to repair that just to go because the truck has to go to this particular thing, the repair truck, to this particular location. So that's the most important point. The second most important point was named reliable and efficiency supply of energy. Because from all we know is that sufficient energy supply is really very much linked to the gross national product per capita, so to the wealth of a country, because that is certainly a very important part of the infrastructure. Comfort and security has also been named, and then last but not least, low emissions. And a lot of mega cities, you know already that the quality of life is very much impacted by the effect of greenhouse gases already today. If some of people of you live, for example, in cities like Mexico City or Beijing, you know it's not that easy in most days of the year. So we are looking for comprehensive solutions from single products to interlinked intelligent infrastructure solutions. And let me step into a little bit more in these 4 topics. What do these 4 topics mean for the smart grid? Let's start with efficiency. Efficiency also has to do something that you somehow get the system financed. And you only get it financed if you get money for it, and if there's a business case behind it. And here's the example of Brazil, where we have huge non-technical losses. So non-technical losses is just that there is energy supplied but not paid for. And this is certainly not good if you want to create an infrastructure. Now you would say, hey, and these losses amount to 1 billion already. So now you would 1 billion euro per year. And now you would say, hey, is this a business case behind it? Because how do you collect the money in poor neighborhoods, even if you have the transparency and even if you are able to write the right bills? The funny thing is, or the interesting thing about this is 80% of these non-technical losses happen on the medium voltage level. Now, you're not all technicians, and you do not know what medium voltage and low voltage means. But low voltage is that what you have in residences, and medium voltage is the one you need for bigger demand. So 80% are happening for industrial companies, for example. Yeah, if you have a big cement factory or a big steel company, you certainly need a much bigger connection to the grid in order for the energy supply, and 80% of the losses happen on that level. That means there is a business case behind it, because as soon as you create the right transparency, there will be a strong willingness also to pay this energy bill. The other thing is that also the regulatory office and the government now reinforce this business case, and that is displayed on the right side. That the utilities really have to pay penalties now if they do not collect this money in the future. So that is one driver also for smart grids. Let's go to the second topic, and you won't have any difficulties to recognize this country. These are the United States of America. And you see there a red circle, and you would say, hey, I remember from my geography lessons that the big lakes are at a different location. And you're right. This is not a big lake. This is actually a major blackout. The blackout affected 50 million people. It was in August 13, 2003. I think a lot of you probably remember it even, because it was certainly found a broad coverage in the news at that point of time. And the economic impact of this blackout in Canada and to a larger extent in the United States is estimated to be $6 billion US. So there you also understand that there is a business case behind it, as soon as you can somehow allocate also the costs associated with it. And so the strong motivation in Northern America, for example, to go into the direction of smart grid is reliable energy supply. Let's go to a third thing. You have an existing infrastructure, and the infrastructure may be in different shape wherever you go. Now, there's an increasing energy demand. There is an even more increasing demand for energy transmission and distribution, because especially with the intake of renewable energy sources, you have in the average a much bigger distance between supply and demand. So you need a much bigger network. Now, if you now want to replace the existing network and then grow and build an additional one, you will never find a business case for that. So you somehow have to live also with the existing network and then grow on that. And you cannot do it and replace all these things. You have to somehow build on that. And one thing you can always do to increase already the reliability is to put intelligence on it. Automation, better protection systems, more line protection systems. Because if you track back most of the blackouts and brownouts all over the world, most have been done because the system was not laid out the right way. And that was not the hardware, it was also very much the software. Because you need a control system that in milliseconds does the right reactions if one feeder line, for example, does not work properly. And even with networks like this here displayed on the photos, you can add a lot of intelligence and thus shape a more reliable energy supply system without replacing the existing infrastructure. So, and the last one is really the intake of renewable energy. And that has been covered already today, also by my previous speakers. That is certainly a strong driver, because renewable energy sources do not constantly supply the same amount of energy. You have wind, and you have sometimes no wind, and you have sun, and sometimes the sun does not shine that much. And you have central and decentralized energy sources. On the right side, for example, you see the wind park of Great Garbour in the United Kingdom, a very big centralized energy intake. You have installations Le May in France, which is also a very centralized photovoltaic plant. And then you have, especially in Germany, but also in other countries, a lot of decentralized energy. So whoever had the pleasure to travel through southern Germany, especially through the countryside, by train or by car, you will not see a single barn anymore that is not plastered with photovoltaic units, because it was subsidized for a long time. And that was a very easy business unit. I mean, a lot of my colleague workers and also myself have co-invested with some farmers to plaster their barns and their buildings. This is already a challenge, actually, because in some areas, even as Germany is not known as the most sunny country, there is already in certain areas of the year or in certain parts of the year an oversupply of renewable energy, especially in August, when all the people in Bavaria are on vacation, in Spain or in Italy or wherever they go. Their photovoltaic units on the roof still produce energy, then you have already an oversupply, and they have to switch off then all the conventional power plants, because that is certainly part of the regulation. So actually, these are the challenges for the grid, and these challenges can, from the technological point of view, already covered and answered today. And let me just lead you through this a little bit, how we as Siemens see the smart grid and what can be offered from the technological side, and then certainly later in the panel discussion probably will also come to the business cases behind it. But there are solutions, and all these solutions are also broadly implemented in different aspects, because you have seen the drivers all over the world are a little bit different. They are not all the same. So you have different starting points also all over the world. And because this topic is so important, and because this topic is very much also linked to the topic of growth, population growth and urbanization, Siemens has not only founded a fourth sector after healthcare and industry and energy. There is now a fourth sector within Siemens, a fourth column called infrastructure and cities. But it also decided to found a dedicated division, Smart Grid, within the sector, which is covering all these aspects, and where I'm a member from. I'm one of the three business units, or I'm leading one of the three business units in the sector dedicated to services, including the entire smart metering value chain. Now let's see. The first one is that you have a lot of renewable distributed generation. That is the one challenge I mentioned. And for that, what has to be done? You want to better balance generation, demand, and you also need then sometimes new business models. I mean, the old world, it was very easy. There was a consumption, and as soon as the consumption got to a certain level, you installed another power plant, and then energy went in one direction. Now you want to get a better balance, and especially you want to avoid and you want to better adapt it to the fluctuations of the renewable energy sources. So second thing is that you have limited generation and grid capacity. I mean, that's very much closely linked to the first topic, what you especially want to avoid are these peak demands. Because they are, certainly if you want to cover these peak demands, then you have to install additional capacity, which is only utilized for a very small part of the year, of the day, or whatever. So you want to somehow shift the management and avoid the peaks. And that can be very much done also for things like demand response, where you have certain contracts for certain users and certain incentives for these users to not use energy at a certain point of time. Supermarkets, for example, are an example where you have all these refrigerators with heavy energy use, and you can easily switch them off for an hour without spoiling anything, because that is a safety reserve. And that is often done already, because then energy is saved, especially at noon, where all the air conditioning work in the office buildings and where you have a lot of peak demand. So that is one way, for example, to shift peak, and you need intelligence for this. IT programs. So a lot of these things are really driven by IT and software. The next thing is you want to have reliability through automatic outage prevention and restoration. That is the one technology you need to really avoid these blackouts and brownouts we have talked about a minute before. And last thing, you want cost and emissions of energy supply reduced, and therefore you need an efficient distribution system. Yeah, you want to have as little losses as possible. Not only the non-technical losses, also very much the technical losses you want to reduce, because it's the easiest way. I mean, if you talk about reduction of greenhouse gases, energy efficiency is the cheapest way to do, because then we have immediately a business case behind it. So now let me go. And the last thing certainly is then you want to have the full transparency. And that is that you are then much faster having the right answers, that you have alerts, that you can better fix the system again. Traditionally you have a lot of transparency in the transmission grid, that is from the power plant to the cities or to the main locations. You have not that much transparency, especially no transparency in a lot of countries, in the distribution grid. That means the feeders to the houses and so on. And that is required now, because, especially also because of this renewable, decentralized renewable energy intake. There you need the transparency. Otherwise, you only have the alternative to invest in copper and more copper and more copper, and that is not the most efficient thing. Yeah? You want to see how much additional capacity you really require. Now, let me go from there into one deep dive into the smart metering value chain. And this really shows you the entire chain. Yeah, it goes from consulting, because a lot of our customers in the utilities have a different starting point, and they want to also to know where to invest first, what to do first, what supports their business case. Then certainly it starts with hardware. These are the meters, for example, or sensors in the system. Then you have a communication part, because you want to automatically read and communicate with the meters and the sensors. You want to switch them off, you want to switch them on, you want to also control load with them, you want to get full transparency, so regular information from these meters. Then you have a head end, that is because you have a lot of different infrastructure equipped to it. You want a system, an IT system, that somehow synchronizes the data. The head end does nothing else. And then you get to the real intelligence, that's the Metadata Management system, where you do a lot of evaluation, and I go into this into more detail, a lot of evaluation, which is very valuable for different applications. And then you come to system integration services and system operation services, because certainly as a supplier like Siemens, you can also offer to operate the whole system, and field services. Now, we don't talk only about electricity. We are talking actually about all media. The same value-added chain, the smart metering chain, is also valid certainly for cooling and heating, or for gas, very much used already, or for water. If you also see one of the biggest demands in the world, and the biggest shortages expected, especially in urban areas, is certainly water. And there are a lot of technical losses in the system. And if you now want to fix the whole thing at once, I mean, you always have to go under the road and it causes a lot of trouble. So you first want to have full transparency. Where are your water leakages? Where do you want to fix it first? So the whole chain is really true for all media. What we typically start with, because we are here also on a common journey, you start with a kind of compass, where you really see what is the current situation, what is the road we want to go, and that really helps also a lot of our customers to see, okay, with limited resources, what is the first investment we want to go? What is the first bottleneck we want to open? What are the regulatory requirements I'm working with before we go into heavy investment along the value chain? Let me set one more focus point, and that is this metadata management system. This is really the intelligence behind the whole thing. And Siemens did also an investment at the beginning of this year. We bought a Californian-based IT company called eMeter, one of the leading suppliers of such a metadata management system, because we thought that this is a very good point to start and further penetrate the whole business. And that is really a strategic control point for us, because it links actually one thing on the automation side, the distribution management system, where you manage your distribution network, with the other system that is responsible for the billing, for the book-to-bill process, also the demand response system, and where you also process this data for further applications. And these further applications, some of the examples are displayed in the lower part of the picture. Yeah, with this metadata management, you can use the data as nothing else than data processing and data evaluation. You certainly can much better manage your outages because you much faster get information where the outage really is, on which transformer, for example, and you are much faster at that point. Sometimes you can even automatically switch off, switch on certain things so that you get immediate effect. You can remote connect, disconnect, especially in countries like the United States, where a lot of people regularly move from one building to the next building. I mean, you save really a whole service thing, so nobody has to go there to switch off or switch on the meter again. It's done automatically and done. You can have different billing processes. And certainly you can also use such a system to install non-technical losses programs. Because what you do is then you look at typical patterns. What should a residence or what should an industry company of this size really consume? And if you then compare the pattern of this respective company with other companies of the same size, and there is an abnormal difference, then there is a high probability that a visit at that company or that customer could be a good idea because there's something wrong. And then you certainly, and that is also very important, and there we come to the consumer, you want to engage the consumers to actively care about energy efficiency. And for that you can have all different applications, and you want to install a customer portal where you can even then manage from your portable certain functions within this energy portal. You can switch off remotely, switch on certain devices. You can compare your energy bill to comparable buildings near you. You can do a lot of interaction, and that is certainly also from the utility point of view a very important aspect to get a closer connection to the consumer and a closer interaction. So one application I want to show you in more detail, because it's actually linked to the city, and it was in the preparation also now for the Olympic Games, because London actually has very ambitious greenhouse reduction targets. They strictly follow and strictly control and monitor these carbon reduction targets. And we helped London to install controlling and IT system that controls and manages the CO2 footprint of the city. The customer is LowCarbon London. It's a partnership formed especially for this application. And it was really first a learning laboratory to simulate future streets to distribution networks from a low-carbon economy. the other important aspect is why it had been such a distributed system. 25% of heat and power is generated in London already from decentralized energy, planned in 2025. So we designed and implemented such a smart grid operation data store, and then got in configuration management to the grid assets configured. So there are certainly clear customer benefits for such a system. And I think, it looks technical, but there's certainly a huge economic value behind. First of all, for the attractiveness of the city, because we have seen at the beginning that cities are evaluated also against their environmental footprint and against their greenhouse emissions. And there is certainly, because if you reduce CO2 that way by increasing the efficiency, you certainly also can save a lot of costs. And certainly now, as London will be very much in the focus during the summer, there was also some time pressure and urgency to install such a system, because certainly London has now a very strong incentive to present as a very good citizens, global citizens, during the Olympic Games. So that was what I wanted to talk about. I think there is now more time later in the panel discussion to deeper penetrate some of the topics. So this is what you could, or what I offer you to take away. Yes, in our sector, Siemens Infrastructure and Cities, we have a lot of solutions there, technological solutions for intelligence and energy efficient and productive deliveries. And there are also clear business cases behind it. We have good solutions to make energy grid smart. And we often cover the entire value chain, as I have shown for the example for smart metering, because a lot of these systems are pretty complex. And you have to understand really the entire value chain in order also to drive the business case, which is even more challenging as most of the industry is in the moment in a debundling state, where power generation is debundled by regulatory measures from the transmission and distribution, and then from the retail aspect of trading energy. But that makes the whole world even more fascinating. Thank you very much.